Hello guys, welcome back. In this video, we're going to look at how we can design a small building using STAAD Pro. Here you see I open my STAAD Pro. I select this new project. Then I select this space. Then I give a file name, shop1. You see then I copy this file name, the shop1, and I paste it to the box just below that. Why am I doing this? It's because that when you save a stat file, you get so many files. So whenever you are working with so many different projects, it's not easy to distinguish whichever is the relevant one. So it's better to save your file in a particular folder in the same name. That's why I'm doing this. Next, I select this meter for length and kilonewton for force unit. And I tap S on this dialog box. And then I select this add beam option. Now let me show you one thing. You see here a folder named shop. It's also the name of the file that we are working now. Now I click on this finish button and our STAAD is opened. Here it is. You know STAAD has a designated work order that you have to work in, and it's from top to bottom. You see here you have two side menus. The outer one is the main menu and the inner one is the sub menus. The outer one you can see setup, geometry, general analysis, etc. And each of these menus have an inner menu on which also you have to work from top to bottom. First, I tap on this setup and then I enter some details here. This box over here. It's not very important, although it's a good practice. In a case where this window happened to have closed like this, you can retrieve it by clicking this icon over here, like this. Now I tap on this geometry tab and I get this graphical grid. Now it's in the XY plane. We don't need that, but we want it in XZ plane. So let's click on this create button and we get this dialog box where we first have to give a name, and I put XZ plane and I select this button corresponds to XZ plane and I click this OK. Now we check this box corresponds to XZ plane over here and it's activated. You can see here. But in this project, we don't use these grid lines, so we turn this off. Here we directly assign our grid points over here in this box. You have your CAD drawing like this and you have all those grid points, and you take these XZ values here in CAD, it's XY, put them as grid points in STAAD like this. Now we go to this tool. This is the tool to bring the front view or the view from the positive Z axis, and it's here. But you see now our beam cursor is the active one. We don't want it now because we don't have any beams right now. What we have now is only nodes, so we have to change it to node cursor, just that. And now we select all our frame like this, and you see, and all of these nodes get selected. Now I go to geometry, transition repeat. From here I select Y, that's global Y. I put here 1, and here in this distance column I put minus 1.5. That means that we have to offset our nodes to minus 1.5 or 1.5 meter to downward side. And I turn on this link stubs, that is to link the nodes with beams inside, and I click on this OK. Now we click on this isometric tool to bring back the isometric view. Here it is. Now let's once again take the front view and select our node cursor and select all the nodes like this. Now go to view menu and then select view select objects only to isolate the selected ones from the rest. Then go to geometry tab and select add beams, and from the drop down menu select add beam from point to point and start drawing beams like this. Now let's just draw some secondary beams. For that let's split this leftmost beam into two equal parts, or just find the midpoint of that beam. For that, first select the beam, then go to geometry and select the split beam option, and you will get this dialog box. Here there are a few options, but we want the midpoint, so just click on add midpoint. Once again go to geometry menu, click on this add beam option, and from this drop down menu tap on add beam by perpendicular intersection. After creating beams, go to view menu and click on whole structure. Now activate your geometry cursor because you have nodes and beams right now, and then go to front view and select your nodes and beams like this, and then go to transitional repeat and create your upper stories. Like this step has already been explained, so I'm not explaining it right now. Those who have doubts regarding this, please go back and watch the relevant portion. Now we got our entire frame, but these verticals are not required, so let's just delete those. And this is our frame. Now everything concerned with our geometry tab is completed because we have no plane, surface or solid. So let's just move to the next tab, that's general tab. First go to property tab, then in this dialog box click on define, and from here set the rectangle section, and you put YD and ZD as per your CAD drawings, and the material should be concrete because we are modeling concrete structure. Now we have defined a section and we have to assign that section to our model, and it's a column section, so we have to select our relevant columns. So first we need to take a view from plus X or minus X direction like this, and then we go to geometry and beams parallel to Y because columns are always parallel to Y here. Now all of our columns are under selection. Now you select assign to selected beams, and then on this assign, and then on this S. You see here in the rendered view that the column orientation we have right now is different from what we want. So we have to rotate the column 90 degree. In order to do that, we have to assign a beta angle. So let's just look into how we can do it. On this dialog box, just right to section, click on beta angle, and then click on this create beta angle. Then put a value in here in degrees. In our case, it's 90 degree. Now you select assign to selected beams, and then on this assign, and then on this S. You can see on the screen the difference it makes. We in this drawing have a different kind of column that is in a L shape or a angle shape in plan. Now let's just look into how we can model that. Go to tools menu, tap on create user table, then click on new table, and in this new dialog box you see select section type, and we have a white flange in it, and just right to that you have an arrow, click on it and you get a drop down menu. From there you select angle because it's the most suitable here for the column we want to model. And then tap on this OK. Now click on this add new property, and this dialog box shown, we have to give a section name. I give CL 40 by 42 because that's the size of our column, and the box corresponds to D. I give 0.4, and in the width I give 0.42, and the flange thickness I give 0.24. If you click on this calculate button, it will automatically calculate all those information provided here, and then you can tap on this OK. Now you can see over here our user created section available. The name is UPTCL 40 by 42. Now close this box and again go to properties. Click on user table. Your new section will be there. Select it, and the box right to material, put concrete because our section is a concrete section. Then click on add, and then on close. Now select the property, use cursor to assign option, and then on assign, and then go to your window. You can see your cursor has changed, and click on the components you want to assign your property, and then on assign, and then close. In this rendered view, we can see some problems to our L column, the brown one. That is, the upper and lower sections of the column are not matching in its orientation. So let's try to rectify that. The error happened to be here in with this column is that of these column segments are different. To hover your mouse over a column or a beam, you can see its direction. The start of the beam will be in green, and the end will be in blue, and the midsection will be in red. You see here both of the column segments start from the same node, so the direction of the lower column segment should be changed. Let's see how we can do it. First select the beam, then go to tools menu, then select redefine incidence, and you get this dialog box with switch incidence of selected beams highlighted. Tap on OK, then that particular beam will be redirected. Now select the next beam and repeat the same process. Now you can see here it's solved. Now it's time to define the beam sections. Follow the same steps that we did before in case of the columns. Now you select assign to selected beams, and the node is assign, and the node is S. If we take this rendered view and observe closely, we can see some imperfections like you see here. The beam and column ends are not perfectly joined. Now let's see how we can solve this. So it's time to deal with the specification tab. Click on the specification tab and we get a specification dialog box. From where we click on this beam and we get member specifications dialog box. From here we select offset, and under location we give start, and under offset we give y value minus 0.225. You know our beam depth is 0.45 meter and we have to lower the beam by half of its depth. That's why we give minus 0.225. After that we add it, and then we take the end location and do the same. That means that assign the same minus 0.225 meter to y again. Click on add once again. Now use your cursor to assign these values to your beams. First you add the start value to all your beams, and then you add your end values like this. This should be done on all floor beams. Now we have assigned all of our start and end values to all of the beams on all of the floors. And you can see in this rendered view that all of those imperfections has been rectified. That's the end of this tutorial. Thanks for watching.